This article is about a class of programming languages. For the method for reducing the runtime of algorithms, see dynamic programming. Dynamic programming language is a term used in computer science to describe a class of high-level programming languages which, at runtime, execute many common programming behaviors that static programming languages perform during compilation. These behaviors could include extension of the program, by adding new code, by extending objects and definitions, or by modifying the type system. These behaviors can be emulated in nearly any language of sufficient complexity, but dynamic languages provide direct tools to make use of them. Many of these features were first implemented as native features in the Lisp programming language. Most dynamic languages are also dynamically typed, but not all are. Dynamic languages are frequently referred to as a Euro or scripting language ESA Euro, although the term a Euro or scripting language EA Euro in its narrowest sense refers to languages specific to a given runtime environment. Examples: the following are generally considered dynamic languages: ActionScript, Bean Shell, CoBoolScript, Clojure, Cold Fusion Markup Language, Common Lisp and most other Lisps, Dylan, Groovy, Gambus, Fancy, JavaScript, Julia, Lua, MATLAB/Octave, Objective-C, Perl, PHP, PowerShell, Python, R, Ruby, Smalltalk, TCL, VBScript, Java, SuperCollider, Implementation, Eval. Some dynamic languages offer an eval function. This function takes a string parameter containing code in the language, and executes it. If this code stands for an expression, the resulting value is returned. However, Eric Muger and Peter Drayton suggest that programmers use eval as a poor man's substitute for higher-order functions. Object runtime alteration: a type or object system can typically be modified during runtime in a dynamic language. This can mean generating new objects from a runtime definition or based on mix-ins of existing types or objects. This can also refer to changing the inheritance or type tree, and thus altering the way that existing types behave. Functional programming: functional programming concepts are a feature of many dynamic languages, and also derive from Lisp. Closures: one of the most widely used aspects of functional programming in dynamic languages is the closure, which allows creating a new instance of a function which retains access to the context in which it was created. A simple example of this is generating a function for scanning text for a word. Function new scanner, temp function equals function, scan for text, end function, return temp function, end function. Note that the inner function has no name, and is instead stored in the variable temp function. Each time new scanner is executed, it will return a new function which remembers the value of the word parameter that was passed in when it was defined. Closures are one of the core tools of functional programming, and many languages support at least this degree of functional programming. Continuations: another feature of some dynamic languages is the continuation. Continuations represent execution state that can be re-invoked. For example, a parser might return an intermediate result and a continuation that, when invoked, will continue to parse the input. Continuations interact in very complex ways with scoping, especially with respect to closures. For this reason, many dynamic languages do not provide continuations. Reflection: reflection is common in many dynamic languages, and typically involves analysis of the types and metadata of generic or polymorphic data. It can, however, also include full evaluation and modification of a program's code as data, such as the features that Lisp provides in analyzing S expressions. Macros: a limited number of dynamic programming languages provide features which combine code introspection and eval in a feature called macros. Most programmers today who are aware of the term macro have encountered them in C or C++, where they are a static feature which are built in a small subset of the language, and are capable only of string substitutions on the text of a program. In dynamic languages, however, they provide access to the inner workings of the compiler, and full access to the interpreter, virtual machine, or runtime, allowing the definition of language-like constructs which can optimize code or modify the syntax or grammar of the language. Assembly, C, C++, early Java, and Fortran do not generally fit into this category. Languages. Popular dynamic programming languages include JavaScript, Python, Ruby, PHP, Lua and Perl. See also, comparison of programming languages, name binding, references. External links. Many use the term scripting languages. Are scripting languages any good? A validation of Perl, Python, Regs, and TCL against C, C++, and Java Euro 2003 study, a slightly skeptical view on scripting languages by Dr. Nikolai Pskov, Programming is Hard, Let's Go Scripting by Larry Wall, Perl.com transcript of his State of the Onion speech. Scripting on the Java Platform, a Euro Java World, further reading, Lawrence Tratt, Dynamically Typed Languages, Advances in Computers, Volume 77, pages 149 to 184, July 2009.